Hi, this is Dr. Aki working with you on the autonomic nervous system. And if you're on page 1 of the handout, you've got a picture of a bear chasing a man. And this gives us the overview of how the autonomic nervous system, which it consists of the peripheral nervous system, that's the PNS, the central nervous system, that's the brain, and the somatic motor system, how that all integrates together to help you see the danger, that's the bear, recognize that that is a danger in the brain, and then get going to try to outrun the bear. And hopefully this guy will find a tree or something pretty soon, because he's unlikely to be able to outrun that bear for very long. And then the overview, autonomic, the two major parts of the autonomic nervous system, the sympathetic and the parasympathetic. And I'm going over just the overview here. The enteric system, if you ever thought you had a gut reaction or a gut feeling, that could be your gut talking to your brain. And then again, the somatic nervous system, where the skeletal muscle is involved. The second page, we're going to do an activity in class drawing the steps of the autonomic nervous system transmission. Slightly different neurotransmitters and where they're stored between the parasympathetic and the sympathetic, but the overall steps are almost identical. And those are the synthesis of the neurotransmitter, the storage close to the synaptic cleft, the action potential propagation, the electrical impulse gets up there and triggers the release of the neurotransmitter, which flows into the cleft, goes across the cleft, binds to target areas on the other side, which then triggers the nerve to fire and keeps going down the chain. Okay? But then something has to happen to reset that nerve. And so we have a reuptake where it's carried out of the synapse, or an enzyme breaks down the neurotransmitter into an inactive form where it could be then retaken up and recycled that way. So parasympathetic nervous system, the neurotransmitter is acetylcholine. And I cover a bunch of stuff there. And the action of acetylcholine is terminated by acetylcholinesterase. And we'll be talking about that in class as well. This is the enzyme that breaks down the neurotransmitter acetylcholine so that the nerve can be reset. And acetylcholine is involved in both the parasympathetic and the somatic nervous system. It's got two cholinergic receptors, muscarinic and nicotinic. And then I've got a section on the effects of cholinergic blocking agents, also known as, AKA, anticholinergics. And this is really important. I'll be emphasizing this throughout this module because anticholinergic side effects, most common side effects that we see, and they're additive. So a little here, a little there adds up to confusion and problems, especially with older folks. Okay. The opposite is acetylcholinase inhibitors, which are used as nerve gas or insecticides. These jam the system on and create excess secretions, the opposite of anticholinergic side effects. And sludge is the acronym that it stands for salivation, lacrimation, urination, defecation, that type of thing, and emesis. So next is drugs that mimic the action of acetylcholine. We're going to be on the next page here. And agents that block acetylcholinase esterase, which actually enhance cholinergic activity, but they do it indirectly. So they're cholinergic. So we're going to be going over that. So that can be confusing at first. So we'll be reviewing that in class as well. Next, the sympathetic nervous system, also called the adrenergic nervous system. These have two major neurotransmitters, norepinephrine and epinephrine. We hear a lot about epinephrine, but actually norepinephrine, capital N, capital E, is the major neurotransmitter in the sympathetic system. Adrenergic transmission, the steps are here. Again, very similar, except that we have monoamine oxidase, which provides enzymatic breakdown. Okay. And then we have the sympathomimetics. That's the word of that refers to other drugs that work on the same areas as the same receptors with similar effects to epinephrine and norepinephrine. And frankly, we use a lot of these blocking agents and stimulating agents in cardiology. So you'll be getting a lot of this practical during our cardiology section. Okay. The major point also with adrenergic drugs are the system, when it's turned on, it's a very general system compared to parasympathetic, which is more focused. We get a near instantaneous flooding of the body of norepinephrine and epinephrine, providing us a flight or fight response, a survival response, which actually shuts down the non-essential body functions, allowing your body to respond to this potentially deadly threat. Next, we've got a listing of the drugs that we'll be talking about more in class, right there. And then I talk about the receptors. We have two major classes of adrenergic receptors. We have alpha receptors, beta receptors, and each one of those receptors has agonists and antagonists. And the shape of the three-dimensional molecule of the drug or neurotransmitter fits into its binding space, its receptor, and how good that fit is determines how strongly it binds. Our overall selectivity, we have alpha 1 and alpha 2. Our alpha 1 is postsynaptic. It's on the other side of the synapse, and it causes direct vasoconstriction. That's really, really important. We need that in shock. We block that to treat blood pressure. Alpha 2 is presynaptic. It's just like a thermostat. It has a feedback function. And then the selectivity of beta receptors. Many of us in pre-hospital emergency care, I was a emergency medical technician for years. It's beta 1, you have one heart, two lungs. Beta 2s are mostly in the lungs, beta 1 in the heart. So the summary of adrenergic stimulation on your organ system is to prepare you to survive a physical attack. Okay, so it increases blood flow and tends to decrease higher level thinking, so that your world becomes very, very narrow with very, very clear-cut responses. We're going to be practicing the QR response in class to reduce sympathetic tone and to see how that feels. Okay. And then we have the rest and repair cycle, which is the parasympathetic or the cholinergic. And para means besides or next to. So the parasympathetic lies on the side of the adrenergic system. And the keys to this system are secretions. Because it's rest and digest, it's resetting the body to where we are healing, we're resting, we're digesting, all those things that need to be in good working order to maintain our body in optimal health. So saliva, gastric acid, pancreatic enzymes, our defecation, urination, and sweat and tears, all secretions. Next, we have drugs that are agonists and drugs that are antagonists listed here as well. And we'll be talking about nerve gas a little bit too and how it works. Next, we have the somatic nervous system, and that's the musculoskeletal system. I'm sorry, I said nervous system, I meant somatic system, which is musculoskeletal. This is under our control. It's how we move our muscles and training our muscles to move under our control. We have muscarinic and nicotinic receptors, and we have acetylcholine. So we have acetylcholine as a neurotransmitter in two different places, parasympathetic and the somatic. Okay? And then at the bottom of this page, I've listed some drugs that work in this somatic system, page 5. Now we're going to be on page 6. This is part of another activity we're going to do in class where we start to put together, well, autonomic nervous system, what happens to it when we have a adrenergic response. That generalized flight or fight response, how does that break down into what effect does it have on our heart, what effect does it have on our eyes, what effect does it have on the hair, on our skin, our gut, our bladder. That's what this is all about. Okay. The next page is the activity of acetylcholine on selected organs. So this is the parasympathetic, and which receptor and what does it actually happen when it's stimulated. All right, the effect of parasympathetic stimulation, another activity in class. And then I've tried to marry the two together a little bit and organize them to where we have some adrenergic actions on the heart and some cholinergic actions on the heart, some with the lungs, eyes, GI tract, and the skin primarily is adrenergic. So we're starting to put the big picture together here, page 8. And then starting on page 9, we go through the drugs that act on the autonomic nervous system drug by drug. And usually I'll go agonist first and then antagonist. And at the very back of this handout, there's actually a study guide that you can use to go through this if it helps you. If it doesn't, don't worry about it. It's not an assignment. It's just an extra assist for some folks who have certain types of learning styles. Okay, so we've got the parasympathetic agents, and now we're into the antagonists, the blocking agents, page 10, and some somatic nervous system drugs here. And then we've got the sympathetics starting at the bottom of page 11. And these all have the way it works, alpha or beta, for example, what it actually does clinically, the clinical use, side effects, and they're not exhaustive. They're just the main side effects to try to lock into your brain, and any contraindications. And if it's a specific toxicity, I will add a comment there as well. Okay, so epinephrine, norepinephrine, isoproterenol, amphetamine, cocaine, phenylephrine, pseudoephedrine, clonidine, prazosin, tamsulosin, propranolol. These are out of your objectives. Atenolol, albuterol, and then some miscellaneous. Just throw them in there because they're interesting. Black widow spider venom is a neuromuscular blocking agent as a neurotoxin. Botulinum toxin, which we use clinically for cosmetic surgery and spasm relief. Labetalol. I didn't use it in the adrenergic system. Probably should have. It's an adrenergic antagonist. But I just threw it in there for the miscellaneous. Monoamine oxidase inhibitor and neostigmine, which is a cholinergic agonist. So that we'll be going through those drug by drug fairly quickly in class. Then we've got the fill in the blank kind of thing where, again, we're comparing adrenergic action and then saying, well, if you blocked it, what would it look like? All right. And then anticholinergic actions on selected organs. What would blocking or antagonizing the cholinergic action of an organ, what would it look like? Okay. And then finally, drugs that act on the autonomic nervous system. This is your study guide. Okay. And I look forward to seeing you in class on Thursday afternoon, July 3rd.